Hello everyone and welcome to another video lecture on vector space. So we have seen so far that while deciding the linear independence or deciding the whether a set spans or a given vector space or not, or to show that a given set is a linear span or not. So everywhere we need to obtain a set of equation, that is system number equation A, system of equation A, which is nothing but vectors or a column vectors obtained from a given vector equation. So in this video lecture, we will be learning about the coordinate vectors or coordinate matrix with respect to a given set, with respect to a given set for a given basis. So let us see what is meant by a coordinate vector or coordinate matrix, which plays a vital role in many simplification. So the topic of today's video lecture is the coordinate vector or coordinate matrix. So let us define first coordinate vector or coordinate matrix. So for this, let us consider a set of vectors say S, whose elements are v1, v2 up to vn. This is a for basis for a vector space V, vector space V, and let small v be a vector, any arbitrary element of the vector space V, and V is a linear combination of all elements or all vectors in set S. So it is C1 V1 plus C2 V2 plus Cn Vn. So any arbitrary element in vector space V is a linear combination of all elements in vector space S. Then the coefficients C1, C2, Cn are called the coordinate are called the coordinate vector or coordinate of this V with respect to set S, and the column vector which we write as denoted as this square bracket within that V with respect to S, that is column vector containing all these coefficients or all these scalars, that is C1, C2 up to Cn. This is called the coordinate vector or coordinate matrix. Coordinate vector or coordinate matrix of V with respect to the basis B. Right, so what is done here? So we have considered arbitrary element of the vector space, which is written as a linear combination of all elements in the basis. Then these scalars, column vector obtained by the scalars, is called as a coordinate vector or coordinate matrix with respect to a given basis. So let's see first example on this. Generally, the question are asked on this particular topic for 2 marks. So find the coordinate vector. Find the coordinate vector of p of x, which is a polynomial that is given by 2 minus 3x plus 5x square with respect to with respect to standard basis. So what is the standard basis of polynomial space of degree 2? It's 1x square of polynomial space P2. So what we will do here? So as per the requirement, this P of x is a linear combination of each element in this set S. Elements in the set S, here we denote them by V1, V2, V3. So P of x is linear combination of V1, V2, V3. So we have this expression which is our given vector equation. Now here substituting the values, various values. So it's 2 minus 3x plus 5x square is equal to C1 into V1 is 1 plus C2 into V2 is x plus C3 into V3 is x square. Now, what we do here? Just compare the various coefficients of x, equate various coefficients of x. So, the way first constant term, let's equate constant term. So, what we get? C1 equal to 2. Then, coefficient of x we will compare. So, we get value of C2. That is how much? Minus 3. And C3 is here 5. So, therefore, P of x, we want coordinate vector for what? P of x with respect to a standard basis. What is the basis given here? S. So that will be represented like this. So it is equal to what? Coefficients C1, C2, C3. So that is 2 minus 3, 5. So this is our required coordinate vector. This is required coordinate vector. Now, here remember the order in which the basis vectors appears in S affects the order of entries in the coordinate vector. So, what are the basis vector? Basis vector are here 1, x and x square. So, remember first we will get the coefficient of constant term, that is C1. Then we'll get coefficient of x, which will be C2. Then coefficient of x square will be what? C3 here. So in that order only we will have to write the coefficient 2, minus 3 and 5. Right. So if suppose the basis given is say x square, here x and 1. So in that case what will be the entries over here? The entries over here will be, first I will write coefficient of x square. So what is coefficient of x square? It will be 5. Then coefficient of x, that will be minus 3. And finally I will write constant term, that will be 5. So this is very important. The order in which the basis vector appears. In that order only we should write the coordinate vectors. So I hope this is clear to all. Now let's have next example. Find coordinate vector. Find coordinate vector of A is equal to 2 minus 1, 4, 3 with respect to standard basis B is equal to E11, E12, E21, E22 of metric space of size 2 by 2. So here one should know what are standard basis of metric space M2 by 2. That is, you should know what are the entries in E11, E12, E21 and E22. So for this you can refer my first video lecture on basis. There this is explained in brief. Now, so what we will assume? So let let us consider A, the given element of vector space M2 by 2 as a linear combination of every element in the given basis, that is every element in the set B. So here we will write it as, say, alpha 1 E11 plus alpha 2 E12 plus, I'll write alpha 3 E21 plus alpha 4 E22. Now we will substitute A, E11, E12, E21, E22. So what I have, 2 minus 1, 4, 3 is given matrix is equal to alpha 1. What is E11? It's 1, 0, 0, 0. Alpha 2, E12 means the matrix of size 2 by 2 where we find entry in 1 2 position and 1 as 1 and rest of the entry as 0, plus alpha 3 E21 will be entry in 2 1 position is 1, remaining all element 0, plus alpha 4 E22 means entry in 2 2 position 1, remaining all elements 0. Now simplify. What you will get, multiply with the element in 1 1 position and then add them, right? So what you will get here alpha 1. Similarly repeated for rest of the case. Now equate corresponding matrices, right? Equating corresponding matrices means equating corresponding elements of the matrix. So what we have, alpha 1 is equal to 2, alpha 2 is equal to minus 1, alpha 3 is equal to 4 and alpha 4 is equal to 3. Therefore, the matrix A. For matrix A, we want a coordinate vector. So, coordinate vector of matrix A with respect to a given basis B, which is denoted like this, which is equal to what? Now, what I have told you, the sequence in which these basis vector appears, in that sequence only we have to write its corresponding scalar. For E11, what we have, alpha 1 here, so we will write its scalar 2, then next alpha 2, alpha 3 and then alpha 4. So this is our required coordinate vector. Now, so I hope the concept is clear to all, how to write coordinate vector or coordinate matrix. So in the next video lecture, we shall discuss the most important portion of this unit, that is a reduction of given matrix or given vector into a row echelon form. And on the basis of that, we will be discussing the matrix associated with a given matrix. So I shall conclude this video here for now. Thank you one and all for watching the video.